Okay, Year 9, welcome to your tutorial on sine, cosine, and tangent, or sin, tan, and cos. Sin, cos, and tan, as we've come to know them. And using those finally, in order to actually do something. Okay, today we are going to have a look at using these ratios in order to work something out in a triangle. So let's begin. Okay, what are we doing today? Well, we've already discovered that there are three ratios that exist in right-angled triangles. They are sin or sine, tan, and cos. There are nicknames for them: sin, tan, and cos. And those ratios exist with different sides of our triangle. So, how do we remember that? Soccer, toa, don't you, Noah? You know that really annoying thing that I was saying before that Denny and Tim are now saying? Yeah, soccer, toa. That's how I remember it. This big long statement. I haven't ever actually broken it directly down for you though. Okay, so each part is a different ratio. That's the sine ratio, that's the cos ratio, and that's the tan ratio. Okay, now the sine ratio, or the S, represents that it's the sine ratio, and it tells me that it's the opposite over the hypotenuse. The next bit is the cos ratio, the cosine ratio, and it tells me that it's the adjacent over the hypotenuse. The last one is the tangent ratio, or the tan ratio, and that tells me that it's opposite over adjacent. So that's why you see me always write down like a crazy person, toa. I always write it down so that I know that it's the opposite over the hypotenuse, the adjacent over the hypotenuse, and the opposite over the adjacent. Today what we are going to do is we are going to have a look at how we can use SOHCAHTOA, or sin, or tan, or cos, in order to work out missing side lengths. We're going to use the ratios that we've known, okay, and that we've learned over the last few lessons, and apply them. So let's have a look. In the past, in the last few lessons, I've simply been giving you questions and asking you to work out the ratios. So instead of actually seeing a degree in here, you've been seeing this thing called theta. Why I've done that is that I wanted you to focus on knowing those ratios. Knowing that a sine ratio is opposite over hypotenuse. Knowing that a tangent ratio or a tan ratio is the opposite over the adjacent. That's what I wanted you to focus on. Now we are going to use those ratios in order to actually get somewhere. Okay? Now I am substituting that theta with actual degrees. What you now need to be able to do is use those ratios in order to find out lengths of a side of a triangle. With Pythagoras' theorem, we were able to find one side length if we had the other two. So if I had the hypotenuse on one other side, I could find one. So if I had C and B, I could find A. If I had A and B, I could find C. This time with SOHCAHTOA, if I have an angle and one side, an angle and one side, I can use that to find another. I don't need two side lengths. All I need is the angle and one side, and I can find the other side. The first thing that you have to do when you get given a question like this with an angle is mark the sides. Which one is the opposite? Which one is the adjacent? Which one is the hypotenuse? The hypotenuse is always going to be opposite the right angle, so I'm just going to mark that as H there. The adjacent is always the side right next to the right angle, so that's going to be the one there. The opposite is always going to be, as the word suggests, opposite the right angle, so it's going to be that one there. Okay. Then what I need to do is, I know that I only need an angle on one side in order to find out one of the others. What I need to do is say, okay, what sides have I been given, and what side am I looking to find out? I have been given the hypotenuse, and I'm looking to find out the opposite. What one of my trigonometric ratios deals with the hypotenuse and the opposite? I write down like a crazy person, SOHCAHTOA. Okay. which one deals with the hypotenuse, and which one deals also with the opposite. Okay, that's adjacent, doesn't deal with that. That's adjacent, I don't have the adjacent. Oh, okay. Sine. My sine or my deals with the opposite and the hypotenuse. So that's the ratio I'm going to use. Okay, that's the ratio that I'm going to use. I'm going to use my opposite and my hypotenuse. Okay, this is how I do it. I say, instead of sine theta and drawing the theta now, I now draw my degree in. Sine 38 degrees equals the opposite over the hypotenuse. So the sine of 38 degrees equals the opposite over the hypotenuse. The sine of 38 degrees, now I substitute in my formula. What's my opposite? Okay, bummer, don't know. Okay, it's x. Okay, over, what's my hypotenuse? 7. Okay, the sine of 38 equals x on 7. Now, most of you are sitting there thinking, oh my gosh, I don't know what Mr. Course is talking about. Guys, it's just an equation. 2 number sentences separated by an equal sign. Okay, what don't I know? What is my objective in here in this equation? What am I trying to find? I'm trying to find my unknown. My unknown in this equation is the x. So I'm trying to take things away from that x. I want to find out the missing side length, or x over here. Okay. Now, if I'm saying sine 38 equals x divided by 7, how do I get that x by itself? Sorry, what's that you say? Do the opposite and multiply each side by 7. Well done, you. Okay, so I multiply this side by 7, sine 38 degrees multiplied by 7 equals, now x divided by 7 multiplied by 7 cancels each other out. So that becomes x. Now, some of you might be sitting there and thinking, I don't know what the sine of 38 degrees is, but it's not an unknown. You actually can know how to do it. And I'm going to show you how to do it, with your calculator. So if you get your calculator, guys, and you jump in and you hit this button here, what you get up on your screen is sine with an open bracket. You then type in 38. Okay, you then type in 38. This is the most important thing. You must also hit this button just here. I'm going to do it in blue. This button just here. This is your close bracket sign. Okay, then you hit equals. Then you multiply it by 7. Okay, so the sine of 38, close the bracket, multiply it by 7, will give you your answer. Okay, will give you your answer on that one. Now, let me, Mr. Corsi, see if she can work this out. There we go. Okay, let's put our calculator over there. And if we do that, and we do that big long calculation, we would get an answer on our calculator of x equals 4.30963, blah, 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 blah. We're going to round that to 2 decimal places. Okay, we're going to round it to 2 decimal places. I hit the decimal point. I go 1, 2. My main thing is that I look to the place next to it. If it's greater than or equal to 5, I round up so that 0 changes to a 1. And my answer becomes 4.31. That's my answer for x. X, or that side length, is equivalent to 4.31. Let's have a look at another example, okay? If I've lost you, stick with me, we'll get there. Let's look at this example. Let's label our sides. This time, opposite the right angle, I'll label my hypotenuse. Opposite my marked angle, I'll name my opposite. Next to my marked angle, I'll name my adjacent. Okay. So I've got an adjacent, an opposite, and hypotenuse. Now, what lengths have I actually been given? I've got a marked angle. I'm going to write saw, car, toa. Been given a marked angle, I've been given a hypotenuse, and I've been given an adjacent. So, a marked angle. Cool, good, I can do something. I've been given a hypotenuse and an adjacent. Which one of these deals with a hypotenuse and an adjacent? Let's have a look. No, it's not. Sine, it's not that guy. It's not tangent. Oh, hold on. Here, let's have a look. I know when I look at my cos ratio, that's adjacent over hypotenuse. And I got an adjacent. Sorry, here. And I got a hypotenuse. Sweet. I can use that ratio in order to find out the missing side length. So I've got an adjacent and I've got a hypotenuse. And my ratio, and my rule, my trigonometric rule tells me that my cosine rule equals my adjacent over my hypotenuse. So the cosine of 24, sorry guys, is my adjacent over my hypotenuse. My adjacent over my hypotenuse. In this side, the cosine of 24 degrees in this example is, what's my adjacent? X, bummer, don't know it. My hypotenuse is 10. Okay, so the cosine of 24 degrees in this example is x on 10. What don't I know? What don't I know in this equation? Well, what am I trying to find? Bugger, I'm trying to find this x here. Okay, so in my equation, I'm trying to get x by itself. How do I get x by itself? Well, if it's x divided by 10, just multiply both sides by 10. Okay, if I multiply that by 10, okay, that cancels each other out. I have to multiply the other side by 10. So it's the cosine of 24 degrees multiplied by 10 equals x. Okay, so my missing side length is equal to the cosine of 24 degrees multiplied by 10. I get my calculatrice out, okay, my calculator. Okay, I again do exactly the same thing I did with sine, but I use this little button here called cos, and it will again bring up a cos and an open bracket. I type in 24. I make sure I use my closed bracket. Please, please, please remember to use your closed bracket. I hit equals. I then multiply that by 10. Okay, and when I do that, I get an answer of x equals 9.13545, blah, 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 blah. Okay, I round that to 2 decimal places. I hit the decimal point. I go 2 places along. I see that next to it is a 5, guys, which must mean that this digit rounds up. So my answer would become x equals 9.14. Okay, I've rounded that 3 up to 4 because the digit next to it was 5 or above. And it's simple as that, guys. Let's have a look at another example. Okay, my very last one. This time, I'm labeling them quickly. This one here's the hypotenuse, it's opposite the right angle. This one here is the opposite. Okay, it's opposite my marked angle. It's really straightforward, which must mean that this one here is my adjacent. Whoops. This one here is my adjacent. Okay, I look at my degrees. Okay, I look at the sides that I have. I have 1 degree and 2 sides, one of which I have a measurement for. What size do I have? I have the opposite and I have the adjacent. If I have the opposite and the adjacent, I know that the ratio I need to use is tan, because that is the only one that includes the opposite and the adjacent. So the tan of 42 degrees is the opposite over the adjacent. The tan of 42 degrees, I substitute into my formula, is x on 4. The tan of 42 degrees, okay, if I'm trying to get that x by itself, I multiply this side by 4, I multiply this side by 4. Okay, that cancels each other out, becomes x. The tan of 42 degrees multiplied by 4 will give me the answer to that question. Okay, and if I plug that in on my calculator, again guys, I don't think I need to do this for a 3rd time, but I will. Okay, if I enlarge my calculator here, whoa, a bit too much. Okay, tan button is over here. Make sure when you hit it in, you close the bracket at the end. Okay, and then you do an equals, and then you multiply it by 4. Oh, sorry, 4, which is here, and that will give you your answer. And when you put that into your calculator, guys, oops, sorry, when you put that into your calculator, let me just get rid of that. These are really ugly as well. There, oh, maybe not. Hold on, hold your horses. There we go. When I put that into my calculator, I get an answer of x equaling 3.6, whoa, 60161, blah, 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 blah. I round it to 2 decimal places. I hit the decimal point. I go 1, 2. I look to the position next to it. It is less than 5, okay? So it means that that decimal stays the same. So x is equal to, let me write this out, or the side length of this one is equal to 3.60. Okay, so that is how I implement sine, cosine, and tangent in order to find missing side lengths.